This page of notes teaches by example how it is that light bulb brightness works, or how it is that power is dissipated through resistors in a circuit when you have multiple resistors and we have multiple batteries. Now, the first thing we need to know to answer this question is that light bulb brightness is associated with the power that is used. And power is IV, I squared R, or V squared on R. For the resistor. The resistor in this case is going to be a light bulb, and we are going to assume that the resistance of each of these light bulbs has a 1 ohm resistor. Anytime you're given R values or values, you're not given R values, but you're given identical things to use, pick nice easy numbers to work with. I chose 1 ohm and 1 volt. So if each of the batteries is a 1 volt battery, and we have a connection like we have here, in A, the batteries are in series. So batteries in series add voltages. So if you want to make 3 volts out of 3 1-volt batteries, you have to connect those batteries in series. Now, we know resistors in series add. So if I have 2 1 ohm resistors, I get my 2 ohm resistor. My composite voltage would be 3 volts. So I am pushing, or we are pushing 1.5, 3 on 2 amps of current through these resistors. So voltage equals IR, so the voltage drop across each resistor is 3 on 2. The power then dissipated through each resistor, or the power of each of those light bulbs, would be 3 on 2 divided by 1 for the one light bulb gives 9 divided by 4, 2.25 watts. So that's A. Now, B is going to be handled the same way. I'll leave B for you to do. C, on the other hand, has same color, same voltage. So here, each of these light bulbs sees the full battery voltage. So you can do your V squared on R for that one. Here, we have 2 batteries in parallel. Now, batteries in parallel do not change the voltage. Same color, same voltage. So here in series, we had 1 volt, 1 volt, 1 volt making the 3 volts. Here we still would have the 1 volt. So we still have 1 volt going across these 2 light bulbs. The difference comes from the green current that's getting pulled in by the 2 light bulbs will be that same green current that we saw here. Well, based on the calculation, actually, it's a different voltage, 3 volts versus the 1 volt. So the green voltage that's getting pulled in would be no different than if it was 1 battery or the 2 connected in parallel. But if we look at our junction here, we're going to have, if we have I here, we would be getting 1/2 I from the lower battery. We would be getting 1/2 I from the upper battery. So this circuit, even though it won't function any differently with 1 battery versus the 2 batteries, the light bulbs would stay on twice as long because we have the second battery in parallel. So here we have our 2 in series, so the voltages add, same color, same voltage. So I will leave it for you to do the calculations to calculate the wattage from each of the light bulbs in B, C, D, and E, and when you unpause the video, you can check your answers. So pause the video and give it a shot. Okay, let's see how we did. So here, for B, we have the 2 in series add, so we get the 2 volts, the 3 resistors in series add, so I get a current of 2/3 of an amp going through each of the resistors. The 3 resistors in series divide, remember they're voltage dividers, so they divide the voltage. That's where I get my V squared on R to get the 0.44 watts in B. 1 is easy, right? 1 is just 1 volt across each, 1 ohm for each resistor. We have 1 watt. And then in D, we have the voltage divider. So they're going to each get a 1/2 of a volt of the 1 volt from the red battery. divided by R. It's a 1 ohm resistor, so we get the 0.25. And here we have the 2 volts, full 2 volts going over each of the resistors, so we get the 4 watts. So the brightest is going to be E, and then A is the 2.2, and then C is the 1 watt, and then B is the 0.4, and then D is the dimmest. So I added this because oftentimes students I found were struggling with how to handle the batteries and the light bulbs or the resistors in these types of connections. So hopefully that made sense. And the last thing, though, we have to look at is would looking at a composite brightness from all the bulbs change the answer? And the answer is no. That would be the same in this case because we have the finite amount of energy to use for all of them. So composite brightness or individual brightness does not matter. So there you have it. You can pause, take a look at this, and of course we can discuss it together.